Hi everyone, my name's Richard Dyer. I hope you've had a good viewing of other talks that have been going on for .NET Conf. I know I've been following along. Hopefully I can give you some insight into a different product. I know I'm on the .NET in production and kind of in real world practices track, so hopefully I can give you something that may be a little bit different than a hands-on kind of hello world approach. So you see the title of my speech is From Startup to a Million Monthly Users, Sports Analytics and .NET at Bleacher Report. Like I said, I think you've probably been watching maybe a few more hands-on kind of real world, in the code, in the editor, things like that. Hopefully this is going to be a little bit more of a narrative of what we've done and where, how we've got to where we are and what we're doing at Bleacher Report. And I'll get to what Bleacher Report is if some of you don't know what that is. But what I hope you get out of this is kind of showing how I went from starting a startup, kind of making an MVP, a real product that we could sell and view and show to people, and then actually take that to market, end up being acquired, then take that to a different company that has kind of crazy different scale and grow with them as a platform and as the needs change of what your customer base, what your clients are using. And all this is in .NET. I know traditionally when you think startups, it's probably not .NET. Everyone's Ruby, Elixir's big now, there's Node, whatever. So this is all in .NET. It's been in .NET from day one, and I'll kind of show you that journey that we took. So half of this is kind of a history and growth of what I've done, and then the other half is where we've gone and how you can leverage .NET in a production environment and hopefully get what you want out of it and do different cool things. So it's kind of real world .NET in practice. So who am I? I'm Richard Dyer. I'll get a little more in depth of what I did as a startup, but I co-founded a company called StatMilk I'll get to that in a second. But I went to Georgia Tech. This is probably 10 years ago, right out of Georgia Tech. I graduated and worked at a big enterprise kind of cube farm company. That whole thing was really not my thing. I worked there for a really long time, but you kind of work in this cube farm and you get to see what are you doing and are you interested in it or not? And I really wasn't. But we were using .NET there, so that was kind of how I got my exposure. I graduated, we had started in Java, switched over to C#, and this was back in 2007, so back in like the 4.0 days. And where I went from there was creating this company called StatMilk, which I'll get into, and then that was acquired by Bleacher Report. So if you don't know what Bleacher Report is kind of the new of sports media publishing. I know I grew up on ESPN. Kids these days, if I want to date myself, kind of use Bleacher Report to get all their sports news. We have what you would consider the coveted 18 to 34 demographic. People have said we're like the MTV of sports. So I don't know, if you don't have the app, go get it. It's great. I love it. But kind of where they started, they were actually a startup in 2007, I think. In 2008, they took their desktop app and kind of went mobile with TeamStream, which we just had a redesign. And they kind of just took off from there. It's been one of the most popular sports apps. It's referenced everywhere. So through that, they actually acquired StatMilk. And I'm about to present how StatMilk fits into all this. For the last 6 years, I've been doing StatMilk. And where this fits into what we're doing and how that fits into the BR ecosystem and platform really does, I need to show some context of how I kind of got here. So what is StatMilk? The idea behind StatMilk was a platform for fans. So aside from Bleacher Report, we kind of still have the same context of fans love their teams, that you want to get notifications of your teams or things like this. As a fan, I love Georgia Tech football. I grew up in the Southeast. College football is huge. So I'm used to going to tailgates. And one of the big things is when you're at a tailgate, you're sitting around, maybe drinking some beers, talking to friends. There's always this kind of narrative of the, elusive stat. A good example is, Georgia Tech versus Virginia Tech. Virginia Tech always wins on Thursday nights. Well, that's kind of a made-up stat. Like, yes, that data is out there, but as a fan, when I'm sitting around a tailgate, is that something that, is it true? Is it, can I prove that? What's the easiest way to do that? And StatMilk kind of was founded on this. So the idea was, I want to be able to look up, Virginia Tech versus Georgia Tech Thursday nights, or Virginia Tech Thursday nights, or Georgia Tech Thursday nights. The big thing was this is a fan-centric approach to data and what we're going to kind of get. That just didn't exist at the time. Like, you really could not see any of this data without going to kind of box scores type thing. So StatMilk, in its in maturity, was founded in 2011 by my friend Dave Marks, who's actually now the senior director of engineering at Bleacher Report. So I still work with him every day. He's great. I'm sure he's listening to this. So hey, Dave. As you see here, it was a single MVC application. So think literally just going to Visual Studio, new application MVC. Again, .NET 4.0 days, maybe 4.5. I don't know. It's 4.0. And then we had 2 console workers, and I'll kind of get to this in a little bit when I expand on how this works. Right now, as long as you just kind of understand the context of what StatMilk does, I think going this way, kind of screen first in, to see how you take what you see on the screen and how it works behind the scenes might be a little more useful if you have not had a lot of experience with .NET, and hopefully I'm not boring anybody who does have a lot of experience. So we launched via Hacker News. It was literally we founded it in 2011. Launched via Hacker News, literally just posted, hey, look at this cool thing. It was a show HN post, and then immediately, it just kind of, I wouldn't say took off, but for us, the guys who just kind of made this website for free, it was awesome seeing all these people having these positive, responses to things. So all this data that we kind of had was, like I said, you could get it from traditional box scores, but one of the big things was that we wanted to kind of fix was you go online on big sports fan sites like forums or whatever, and these little silos, and people would have spent all night just kind of looking and going through this box score data to get that Thursday night game experience data. So we launched it just literally on that platform. Cool website. There was no concept of making any money. So yes, it was a startup, but in the tradition of hey, let's make a cool website of things we like. So launched it in 2012. A month later, we did an iPhone app. And as you can see here, the TechCrunch did kind of a little expose on it. The reason I'm telling you this, again, is so you kind of have a context for the more in-depth of the technical challenges that this faced and how it works. So hopefully I can give you a demo. So here is the StatMilk website. It's a running legacy, legacy data. If you kind of look on here, it's 2014 data, so really old. But I don't know how much you know about sports. Here's college football team. So these are all mixed in. You see big Alabama, Army, whatever. The kind of meat and butter of this is everything is real time. So I want to see Alabama. Click Alabama. Here's their 2014 season data. You see they have 4.0. Cool. This is kind of what you would get if you went to ESPN or Yahoo or the traditional kind of media sites. This goes a little bit more. We kind of focus on visualization, but this gets you, oh, this is some cool information on the sports. What the bread and butter of the StatMilk platform was, say I click filter stats and I want to see, 2009 home and away games. You update the stats in real time and immediately comes back. So there's a lot going on under the scenes, and I'm going to get to kind of how that works and what pieces of .NET kind of power this. But the big thing is, oh, that's real time, these cool visualizations, things like that. And like I said, it's real time. That's a really important thing on how we framework the architecture. You click away and it goes back to 2009. See how fast that is? It's kind of a big deal. So hopefully I'm not talking too fast, trying to get to the actual meat of this. So go to, that was just in case it didn't work. So our framework design, kind of like I said, we have real-time data query processing, highly available. If somebody clicks on something, make sure that it actually comes back and they're not just sitting there waiting. I think you've probably seen studies of people have a tendency to 2 seconds, 3 seconds, whatever. In that context of how it works, It needs to be fault tolerant, something anyone could use. So that's kind of UX, UI design. I'm not going to touch on that too much in this talk. But at the same time, this is our bread and butter being college football and NFL. We wanted to be able to support expansion and growth. So make sure as you're developing and kind of building these things, don't over-engineer up front. I think we've all probably worked at places that have kind of, you spend a lot of time in design meetings and things like that, but make sure that you have design considerations, but don't send just in the planning phase forever. So here is the StatMilk platform. I'm going to spend a little bit of time on this slide because this is kind of the bread and butter of the pieces in .NET that work. So I'll give you kind of a walkthrough of how that example I just did. So the clients at the top, depending on, think of those as like a browser or outside connection, things like that. The view manager is the MVC app. So that is your new MVC template, whatever. There's controllers for the NCAA, there's controllers for NFL, there's controllers for handling if I want this query of 2014, things like that. It takes in that request of Atlanta Falcons or Alabama football 2014 home and serializes that using MD5. So you'll get a hash out of that data, which is unique because the next person coming in that wants to see Alabama football 2014 at home needs to be able to see the same thing. It's the same request. You shouldn't be reduplicating that work. So we have our data cache, and in that initial load, that was MongoDB. We kind of built it extensively so you could do a lot of different things with it. It looks that up as a key value store, checks to see if that data is there. If it is, it just returns that data. It's a structured object of, oh, here's their record, here's their team name, here's their logo, things like that. However, if the data isn't there, it'll insert a placeholder record. That record will say that the data is queued. You don't need to queue it again. So any subsequent requests that come in know, oh, somebody's already queuing this, like I don't need to do anything. And then that initial request will actually go to a message queue. We were using MSMQ at the time. And then that would be forwarded to Serial. So these names are going to be reused a lot. So just think StatMilk front end, Serial, and Wrangler. Serial, as the name kind of implies, would take that data request and see, oh, I see Atlanta Falcons or Alabama 2014 home, and then do the lookup in the database. So it's the only worker actually doing the database. So as all these other requests are kind of in the front looking for that data, there's really only one worker doing it. Format the data it needs, and then place that data back into the data cache with the appropriate actually populated data response. So all clients kind of expected the same thing. You'd get a view that was, I know that this is Falcons or Alabama or things like that. They would always see that the data came in the same response. The one thing that I will get on this, and this plays a part into how this kind of expanded, was the clients at the time, I think I said it was .NET 4, we weren't doing async await. So when they did that initial request, the first thing that came back would basically be a wait message. And then the clients via JavaScript, or if it was the iOS app, would just kind of set a timer delay, would send a request again until it finally got a response that said no wait. This not optimal. It's making a bunch of extra requests. It's not, you're dealing with weird timeliness issues. If you're delaying, you could be waiting like another 30 seconds. It never took that long, but you could be waiting another 30 seconds when you really don't need to. So this is the overall architecture, and generally speaking, it hasn't changed. So you have your data cache, you have your warehouse. I'll talk about Wrangler a little bit in later on how that's expanded and kind of played a bigger role. And then you have Serial. And then these inner working pieces are really what the bread and butter of the StatMilk architecture. So we have this cool website now. What do you kind of do with it? I think we never, like I said at the beginning, we never actually planned on monetizing this. I wouldn't say never, but it was like, oh, if this takes off, that's cool. If not, no big deal. Again, no real idea of what really to do with this other than we were getting contacts from like SB Nation, that's another online publisher, various conferences. We did kind of startup rally, things like that. There are a few media companies, a few of the actual like football conferences. I know we talked to the Pac-12. They kind of reached out and were like, oh, what could we do with this? One of the big things that kind of ended up being a weird story later on was Turner Emerging Business kind of met with us, and we sat down and went through that whole demo I kind of just did with you. And they even were like, this is really cool. well, what do we do with it? So after that, I think we kind of had to sit down and we're like, well, clearly there's interest in this. You know, our core thing is kind of proven. How do we take that and do something else with it? We came up with a product called Whiteboard, and you'll kind of notice all of our names have either Cal or Stats or Wranglers, whatever, Whiteboard for football, things like that. So the idea behind here, one of the big asks from the AJC locally in Atlanta when we were still in Atlanta was like, cool, we want to use your product on our actual website for news articles. So say the Falcons are playing something or Georgia's playing this weekend, you know, how can we actually show that data? We wanted to make that easy, just as approachable for fans and things like that. So you'll see the idea was basically to take the legacy StatMelt platform that we had and put save configurations on it. So if you want to talk in .NET kind of nomenclature, we added a new controller for Whiteboard. And you'll see here the endpoint is NFL. That next number is actually an identifier. And the last one is an account ID. So we could do a quick lookup there. See that query and that lookup should be the Atlanta Falcons versus the New Orleans Saints, and then make that request that I kind of gave you an example of in the first example. Then that would go to the StatMelt framework. It does the whole thing with serial, the data cache, and returns the data that it needs, and then outputs a response. The good thing about this is, say if somebody was using the traditional StatMelt front end and looking at that same data, if any of the clients for Whiteboard came in and wanted that same data, they would get the same response. So again, we're kind of sticking to our initial ideas on how the framework should work. Excuse me, and leveraging the power of the platform. So next, I will give you a screenshot of kind of how that looked. This was on the AJC webpage. This was an iframe. That was, again, back in, I don't know, 2012 maybe. So that was the best thing. Luckily, they had this cache, and this is not the Falcons-Patriots game from the last Super Bowl. I would never show that. I would just not have shown a screenshot. Perfect example, though. This shows, you know, the same kind of data that we had from the traditional StatMelt, but kind of tailored for their look and feel. So it's the white background, colors that kind of match and favor what they're doing. And that was all built into the Whiteboard product. So now, this was kind of where our version 1 at the time was. You know, it works. It works great. I showed you that initial slide of what our goals when creating this platform really were. So, and we kind of stuck with all those. It was pretty simple. We had 2 console apps. I forgot to kind of mention that. Serial and Wrangler really were just console apps sitting on one server. And, you know, it worked. It was production tested. You know, we'd see traffic data coming in before that, like Falcons Patriots game or Falcons Saints. I think that was the time when the Falcons were in the NFC Championship. So we actually had a lot of traffic, probably more like 130 concurrent users, but we were pumped to get that. And the general gist of the system was, you know, you could add new sports, just create new data models that represent that. And as long as you had those requests up front, you'd be good to go. The bad was, you know, I should also say we did have scaling options, but the bad was those scaling options were painful. So I'm not sure how familiar everyone out there is with, you know, traditional deployed architecture, but all of this was sitting on one single EC2 instance around on AWS. So that one EC2 instance was running the Mongo client and server. It was running SQL Server, it was running the 2 console apps, and it was running, you know, the IIS web app of StatMelt. So anytime if we wanted to scale out, we'd have to create a new instance and either, you know, build up just the Serial clients or the Wrangler clients, or, you know, reduplicate the database. It just made things a little complicated when you're kind of dealing with this weird single container. You know, everyone loves Docker and everything now, but that's a little bit more automated and makes a little more sense. This was literally hand deploy these instances and orchestrations, and it really just wasn't that great. And honestly, like, all these other things are great. The worst thing about this is we were paying for it. Now, the amount of traffic we were getting wasn't a ton, but it did make, you know, end of the month having to pay that AWS bill wasn't the best, especially because, you know, we are on SQL Server. So at this point, kind of what were we going to do? This was acquisition, and this is where we're going to kind of get into the bread and butter of this being in production. So our data provider that we would get all of our data from was called Sports Radar. I think they're Sports Radar now. They were Sports Data at the time. Bleacher Report was actually talking to them to kind of get this same type of functionality that we had with the whiteboard product. So one day, I think we got a call from the biz dev guy at Bleacher Report, and it was like, hey, we talked to Sport Radar, and they said you were doing something cool. Could you give a demo with us? We went back to Turner, gave them a demo, and we went out to San Francisco, where I live now, and met with the team, and they were like, this is really cool tech. We don't do anything with scores. Most of our stuff is kind of fed to us from Turner. We'd love to have you on. They saw us as kind of a lean team. It was just myself and Dave Marks, and it was like, oh, cool, this is something awesome. Kind of going back to the call out from before. I was working at a Cube Farm-ish type place. I was just I had a lot of freedom, but I wasn't passionate about what I was doing. I was doing like insurance risk adjustment products. It's not the coolest thing on the planet. So met with them, and they were totally on board. Bringing us on board is a done deal. I'm not super rich or anything, so don't think every acquisition is the greatest thing. We didn't really spend any money, but we came out on top and didn't have anybody to pay off. We didn't take on any money. We were bootstrapped from the start, so cool. The big thing though was, and I think about this all the time, it kind of drives me what I'm doing at work, is Dave had actually asked me, what are you going to do on day one? And that was a big consideration of, do we accept this acquisition or not? Because am I going to go in and still be able to use .NET? Am I have to learn, they were Ruby at the time. Am I going to have to switch over to them? Luckily, that was not the case. Otherwise, I don't think we would have, kind of taken on that challenge. So we were acquired. This was, 3 years ago-ish. First thing to do, kind of take a stock of your platform. And hopefully, if you've been hanging on this long, I'll kind of get into the meat of how this works now. At this time, this was old .NET. This was, like I said, .NET 4 and Web API 1. So a lot actually has come out since then. There was no async await, things like that. The clients were still polling at the time. Deployments were absolutely awful. You'd RDP into the server, basically make a backup of the directory, copy all the managed code on there, restart IIS. We really weren't ready to scale. So think of big events that could happen in certain types of events. So like NFL draft, different polls come out. You got to take stock and figure out what you're going to do. So this was I think probably the first month was literally like, all right, we got to get on AWS, take what we know about our platform and kind of, make it big, even though we had never really messed with a lot of those kind of concepts that, even Azure and AWS and Google and the cloud kind of hosting service providers give you is don't think of a machine as something that you need to babysit. If a machine dies, get rid of it. So here's kind of where we were probably month one. First thing I did was upgrade everything to .NET 4.5.2, I think was, if I can remember correctly looking at our code. Everything became async await, so the clients no longer had to poll. They could just kind of long connect and wait, and we actually saw immediate responses that were faster. No more polling, whatever. The SQL Server, we migrated to Postgres. That was Bleacher Report at no point ever made, and Bleacher Report and Turner as an extension, never made anything that, they said, you want to buy SQL Server, that's fine, but no one there was using it. So from an operations perspective, that kind of makes things a little tricky. And the big change, I would say, that actually migrated from, all right, here's something you could kind of run as a Hello World app. Yeah, it was on our desktop. It was an EC2 container. We migrated all of those working pieces, so Wrangler, Serial, and our front end, into EB containers. So if you're not familiar with what those are, that's Elastic Beanstalk. And it's kind of a orchestration utility. It's definitely for beginners. We're kind of hitting up some limits on that now. But it's really great. You kind of give it, all right, we need these environments with these applications. You specify instance size, things like that. It has load balancers in it, and it's great for scaling out, scaling up, however you want to do it. The big thing that's kind of weird if you think of back to the architecture, Serial and Wrangler were actually console app. So how does that work with them fitting in Elastic Beanstalk? So Elastic Beanstalk is a web server when it's .NET. Kind of weird, but from a deployment and orchestration standpoint, it really made sense to do that because we could scale up and down and start different number of threads. So serial changed from just being a console loop. We'd use queue_background work item, which is kind of a managed app smart container in the .NET 4.5.2. So what's great about that is we could kind of listen to startup and shutdown messages from the server. Really didn't matter in the long run because if a server died, we'd just start a new one and it would kind of automatically orchestrate itself. And then Wrangler was kind of the same thing. So instead of, if you want to just kind of break it down into how this works, yes, it's not a web pipeline, but the message queues were the actual request pipeline. So instead of hitting some endpoint on the server as an MVC app, it would just listen for connections in a message queue. And finally, I think this is a really important thing because we were never taking advantage of this. MS Build is great. We would literally just build in Visual Studio in release mode, copy paste, for no reason other than we just never looked into it. But MS Build, deploy, and here's like the command we use that would kind of package our container, was the thing that really got us to make it so, all right, we just drop whatever that output was. I think it ends up being a zip file. There's a little bit of configuration in there. It's just a JSON. Drop that into AWS and you're good to go. So that was a huge change. So literally overnight, we went from this one EC2 instance that if that thing died, we were dead in the water, to, all right, I can click a button in Amazon or on my machine, can kind of do some things. And overnight, we went to this auto-deployed, auto-scale thing. But at the same time, it was never tested. One of the big features on here is Amazon's thing is the load balancer. So as part of an Elastic Beanstalk orchestration, they come with Elastic load balancers. And those can look at different metrics on how you want to expand and grow. One of the things I think, so for StatMilk, the front end piece, is that's obviously web traffic. So if you see there's a ton of web traffic coming in, all right, there's some kind of peak in something that we've done or something that was alerted that we need to see, kind of grow out, or typically you're not going to scale up, but we'd scale out and add more servers to the pool. And then for Celia and Wrangler, because nothing was actually hitting them, depending on what they would do, would actually kind of trigger if we need to scale out and scale up, or scale out. And usually those were if there's a ton of messages in the message queue, or there's a ton of network traffic, because those are kind of getting data from different places that shows like, all right, we're kind of seeing an increase in requests for something. It didn't really matter what it was. Add more nodes, and then the request will happen a little bit faster. Finally, and this ended up being the biggest piece, we added Fastly to really provide the CDN front for us. We were using CloudFront, which is the AWS solution. It worked great for our kind of small little mom and pop, only on the AJC website solution, but we were seeing weird cases where we'd go into the CloudFront console and purge data, and 3 or 4 devices would work great, and then there'd be one device that would have that data cached for up to 12 hours, which really, if you're dealing with kind of stats and stuff at the time, was, yeah, that's okay, but not really the most optimal solution. So we switched to Fastly, which at the time, I think Bleacher Report was kind of evaluating as a new customer or provider for our CDN, and they were kind of taking off at the same time. And honestly, like, they've been great. You'll see how we utilize them very heavily in a little bit. We were kind of the first at Bleacher Report to use it, and now pretty much all of our products use them for smart routing, for CDN, we kind of do some weird stuff with our static assets, things like that. It's been great. They're awesome. So that's kind of where we were now. So if you look at this architecture is pretty much the same as the other one, but I put in these little orange boxes for you because that just shows ultimately, instead of it being a console app or just an MVC client on the front end, now these are Elastic Beanstalk containers. So we switched over to Redis as our data cache, but from a functionality standpoint, it's the same thing. In Mongo, we were literally just key value storing, and now we were just using Redis Labs. No big difference there. And this is literally just an updated graph of kind of what I did before. You'll notice there's a big hole in the upper left corner, and I'll get to that later on how we kind of expanded our platform. So at this point in the, I don't know, life cycle of what we're doing at Bleacher Report, they kind of wanted, all right, well, we need real-time support. I don't know if you could figure out, because I didn't really expand on it, the way that the StatMilk platform had traditionally worked was that Wrangler ETL software would go out to Sportradar, get the data, and then we'd just kind of manually clear out Redis. So at any point in the day, like the stats that were stored in Redis really were kind of just what they got last. But say I'm watching Thursday Night Football, or all the games on Saturday, or the Super Bowl, or whatever, it's not going to be updated till we manually call Wrangler to go out and get that data from our Sportradar provider. Because of that, in the nature of how we were caching things, ultimately the real problem there is caching is hard. So you have all these different moving pieces. Say I get stats for Atlanta Falcons 2014 season, 2017 season, what really affects those stats? So a player could get hurt, a game gets canceled. I know that's going on right now with the hurricane stuff. So their schedule changes, their opponents change, the records change while a game's happening. Instead of it just being this key value store that we could kind of kill all the time, you really have to think long and hard about what you're really doing. So at this time, we kind of took a step back to realize, how are we going to leverage our platform to be able to correctly handle real-time data and still maintain those kind of core tenets that we had set up initially. I think people have probably heard there's two hard things in computer science: cache and validation and naming things. That's definitely the case here. It was initially like, how are we going to track all this? So we did come up with a solution, and I'll give a shout out back again to Fastly. And then there's an open source library called cachingframework.redis. They are built on the Stack Exchange Redis. They support tagging your cache keys. So back to that initial example of I'll just use what's on the screen to make it easy. There's NFL 2016 Falcons data. So that could be schedules, scores, stats, whatever. What I can do is generate that serial result, store it in the cache, and then actually tag that key with these different values. At the same time, Fastly actually has a process for kind of tagging your endpoints, which are surrogate keys. So in the header of the responses, when Fastly goes to your origin server and gets that data, they'll see this surrogate key field in the header and know, these are field values I want. So you can see here in this example, as long as you tag them with the same thing, you're kind of good to go on, say I want to clear all NFL data, or say I want to clear 2016 data, or just the Falcons, or some kind of combination of both. Here's how you kind of do it in code. This is a really simple example, but using the caching framework Redis, that's literally all. It's a one-line change, and kind of adding the thing is the same at the top. And for the Fastly API, it's literally just a RESTful API. So you have your kind of secret key, and then the key is the surrogate key that you clear. So it's a really simple method. It gives you kind of flexibility of either doing it manually, or kind of, say I run a Wrangler process for grabbing NFL data or just Falcons data, I can just clear Falcons data. And the big thing here is it gives you the ability to cache as much or as little as possible. So that, all in good, worked really great. We weren't really doing a lot with it, but we would automatically start running our Wrangler processes, and cool. We're probably, I don't know, 2.5 years ago, something like that. So it was NFL draft 2.5 years ago. Yeah, 2 years. And that's kind of the real test for our first platform. NFL draft at Bleacher Report is one of the biggest nights at Bleacher Report. Just from how you can expect the traffic. There's this huge buildup from sports fans. Everyone's sitting around watching it. Articles are getting written on, here's my prelim draft thing, and then something gets released on Instagram, and that player's going to drop. So there's all this news going on. We see crazy traffic spikes. We're all sitting around in the office just waiting for something to break. Hopefully not. But it's a huge tech challenge, because those have been our record number nights. And that was going to be StatMilk's first kind of, what are we going to do here and see how it goes. The one thing here that was really important, because it was the front page, which is where our widget was going to be, we didn't want to kill everything because we had other pieces that would kind of hit it. And so this is where that real-time caching strategy would come into play. I'll give you an example of how this works, but the flow of the data is essentially this. So this is kind of a simplified flow chart. But the services on the left are, you think, the web server and Wrangler, things like that. So that initial state is going to be an empty draft. Fastly and Redis will get that initial thing, and from the client, from their perspective, they make that first call. They go to bleacherreport.com, see that first call. It hits Fastly. If nothing's in there, it goes to the services. It sees nothing in Redis, and it returns basically, oh, here's an entire list of picks. First pick happens, which at this time was actually a manual, like a writer putting it in. You'll see the store in our services. So Wrangler would actually store that data. And then it would call that flush method that I kind of gave you the quick code example. Fastly and Redis at the same time get that flush response. And then in the meantime, this is all basically happening concurrently. That next client is like, oh, I need to see what the draft data is. It goes to Fastly, which will then go back to the services, and it sees, oh, here's what the data you need, and it'll have that first pick populated. That goes back and is stored in Redis, and then Fastly actually caches that data, depending on what our TTL was. And then it goes back to all subsequent clients. So if you'll actually see, the biggest thing here that's probably important are the individual lines versus the multiple lines. Like there's generally only one line, so there's one request that goes back to our backend services. So they're really kind of there just to manage that exchange of data from our data stores into the front end. And then Fastly kind of really, thankfully, takes care of, all right, we know that only the first pick has been made or only the second pick has been made, and gives those to any subsequent client. So Fastly is huge in this. Just another example of, and again, kind of looping back to the initial part of this talk, is what to think about what your actual architecture is when you're designing your Hello World app to represent something later on, excuse me. So worked great. Our tag was, NFL draft 2017 or 2016, 2015. Purge that when anytime a pick was made. One of the really nice thing is you can actually warm up the cache. So in between flushing Redis and actually flushing Fastly, you make a request to Serial saying, hey, I want 2016 draft. The next request right after you flush Fastly is already going to have that populated. So different ideas on different kind of concepts depending on what your architecture supports. And all this easily done in .NET. That was kind of the beauty of this. It handles message queues, it handles threads. Wrangler and Serial are hugely threaded apps, being able to support up to 50, depending on how many you want. So the idea there being I was familiar with .NET. I didn't have to think when we were adding this caching stuff, how do I do this in .NET? There's either a ton of Stack Exchange answers or there's a ton of libraries on NuGet, and it just was super easy to add this. Now, up until this point, I've said everything seems fine and dandy, and generally speaking, it was. I think there's one more slide. Actually, that was the first real test. So before this, kind of like I said, we probably had 130 concurrents from the whiteboard data. I think it was like the NFC championship when the Falcons were in, when the AJC was showing something. They featured it on their front page. Super cool, whatever. Our first night of NFL draft was, 70,000 people, and that was literally overnight. So that was huge from a, startup. We had never done anything wide scale, and that was, I don't want to say a concern, but it was definitely like, how are we going to manage this and handle this moving forward? So that was huge for up overnight. It worked, and it did it live, and it was great. Like, it was a proven solution for our problems. I will say there was a little slight hiccup. When we were testing this, our dev environment was sent to the front page, and that was fronted by Fastly, but we had a bug in our code where we were posting data. So I don't know how much you're familiar with CDNs and how they're kind of configured for routing rules. By default, you're probably not going to store a post data. That's data you're posting to the server. It wouldn't really make sense for Fastly to store that. Then you're going to get weird overflow of data that's not actually saving on your server. What ended up happening was our backend server would get all these, and then our Redis connections would overflow. So not really that great. We had like a really small service. Immediately at the time, we were using New Relic, and it just kind of crapped out. Like I think within 5 minutes of starting a new service, the server would be dead. Luckily, we had New Relic, and they kind of gave us some insight. You just see red errors everywhere. We were alerted to it. Easy to fix, just something to kind of take away, and that would be don't post when it's a get. There literally was no reason for us to be posting. Code reviews probably would have caught this because it was literally just a copy-paste bug. And then there is a good practice with loading Redis, and this is actually if you look at loading Redis connections, because people try to use them as multi-threaded, and that's really not the way the Redis connections work. Load it correctly, and we probably wouldn't have had as many timeouts as we did. So quick takeaways from this, trying to hurry up so we can get to the meat of this on how we use .NET today and what we're actually doing with .NET Core. So at the time, this was a few years ago, we really just started adding new sports. This is just a growth part of the history. We added MLB, NBA, college basketball, kind of soccer. Soccer is a very weird sport to model when relating to other sports. Players can play for multiple teams. Matches fall from one tournament group to the next. So again, when you're modeling your stuff, like we could have maybe engineered this up front, but it would have been over-engineered and made other things kind of difficult. Version 2, here we are. It still works. Multiple scaling options that we actually use daily. We have all these new sports. Production's really been tested. We have true monitoring with New Relic. We have kind of health checks that send us stuff. Unfortunately, we have a ton of spaghetti code. And because of that, we have these weird unclean abstractions where the data doesn't really match easily how everything kind of works in the code. It really is like, so you'll have college basketball having one thing that doesn't really work in relation to NBA. One of the big things was like, say I wanted to now look at, second half of college football and college basketball season, because those data models were completely separate, it would spend probably 2 days adding the single field. One of the bigger examples was, we didn't support preseason for sports. That would then made it so that I think I probably spent 2 days just adding that field, when really it was just a new field in the database. So kind of a state of the union of like taking introspective look of what you really want and how you're using your platform. So this was, I don't know, 2 years ago, or no, this was maybe a year ago. Really was looking at how we were using the platform. A lot of that stuff, we didn't have the front-end client anymore. Whiteboard wasn't really being used. We had a few pieces of widgets that were being used. So we'd have, NFL draft, NBA draft, some other pieces of high volume traffic, but they weren't being used in the same way that we needed people to continually kind of update them. So here's how like our old request structure was. I'll try to hurry through this. Basically, if I wanted to look at something in serial, I'd make a new request, set the value, and then send that to our message queue. The problem was every new instance, just from the way that we designed it, so you'll see in our NFL team stat query, had to kind of override this one method instead of dynamically generating that string. That was the fact of it. So say I wanted to add a new one for NFL small team query, I had to do that manually. It just was not, there was no base done to that. So how do you fix that? Our new serial request on this, our base query object basically has a list of fields that you add to it. So using expressions and generics, you can just add a value. So this NFL team value, it has a team ID for it. So NFL team has a team, a conference, a division, things like that. Our request object and structure building would literally just add those column expressions, and then when you would actually make the request to serial, it would build it dynamically based on this list. And this works primarily because we probably only have 2 or 3 places where we're now generating these requests. Pretty much only one place on the front end is doing this. So that works. Same kind of for our data model. So the big thing with our data model, like I said, you see here, game also has football games, basketball games, which then go down to college games, NFL games, and NBA games. The big thing in our code was that was just not abstractly put together correctly. So the object-oriented programming, like 101, was just not done correctly. We had a bunch of, so in NCAA game, we would have, quarter, and NFL game, we would have period or something like that. There was just a lot of invalid data across the two. And then that took a long time to kind of to reconcile. So we actually ended up making a code generator, or I made a code generator that would look at our data model in the database and find these discrepancies. So if a field was named date change versus date added, it would kind of throw an error. And then it would also compare field values. One of the biggest challenges on why we didn't have proper object-oriented models was because it would be a Boolean in the database for one thing and like a small int 0, 1 for another. So we kind of had to reconcile that, and the code generation now actually handles that whole data model generation, throws errors. We run it on the build server. So say I'm doing something and I only run it locally. My code will compile locally, but when I compile the data for and push it to the server, it's not going to maybe, if I'm checking against staging or whatever, it's not going to actually compile. I'll run the code generator, it'll generate the models, and my code may call some field that doesn't exist. I'll get a compiler error. It takes 10 seconds to run. It's a huge benefit to our process. And because of that, our data query objects are kind of a lot cleaner and nicer. So whenever you would request something to serial, it would kind of do the same thing that, actually it is the same thing to serial, but we use them the same way. You kind of just set this value in this massive object and then build your queries manually. So our data abstraction layer, when we would deal with the database, would check these values individually. This is actually something we could probably open source because our data model doesn't have a ton of joins in it just from the nature of how we do it. The beauty of it is if I want to create a query, I can do it dynamically and the SQL is generated automatically. We use an open source library called dapper.net and extensions of that kind of for the ORM just out of, we're not really doing anything crazy. We don't do any of those crazy joins. Beauty is here you see I add a query value. It's the same thing. These NCAA query team ranks is actually an extension with a generic type associated with it, that type being NCAA team rank. And those fields, it knows that it has season ID, poll ID, things like that, and I can just query it asynchronously. And at the bottom, you'll see that the poll ID, or the SQL was generated and it's all parameterized, it's all nice. It's just a lot easier if I want to dynamically create these things. And the big takeaway here was this refactor really required us to look at how we were actually using the data. So we had this platform and framework that was great given the front end code that we were using at the time in Whiteboard, but now that we're in Bleacher Report and how we kind of don't really use the widgets the same way, there's only 5 or 6 that we were doing. That really was the takeaway from, what do we actually need from this framework? We had a ton of dead code. And the big thing is, at the time, we knew that we were going to be growing. So one of the big things is we were going to start taking over. When you click on a team or you click on our score bar, you see data that's provided by StatMilk. I could get into why that's not the case, but that's not really the point of this talk. So the big thing here also was dependency injection. I'm not going to spend a ton of time on this. The big takeaway was we were really late to the party on this. But once I'd had all these iterations of how our platform was used and we were kind of stable, we had this one singleton, this web global object that literally handled everything. It handled all our connections into the database. It handled all of our creating and destroying any message queues, things like that. Anytime you change anything, that literally would affect everything. There could be compiler warnings and views that we're not checking. So I took a step back and kind of like, all right, here's our functional pieces of code. What we're using, and I think this was the huge thing, we were still on 4.6, or I think at this time we were at 4.6. We actually used the newer dependency injection service resolver that is shipped with .NET code. And I know they've spent, or .NET Core, I know they spent a lot of time making it work with classic framework and things like that. So that has been huge. We knew we were going to be migrating to .NET Core. And so being able to kind of take something that we knew would work out of the box in .NET Core really was a huge benefit for us. I knew that I'd be able to just kind of drop in our code. And I actually had a conversation with Scott about it. It literally was, he's like, yeah, it should just work. And it does. I think this graph kind of speaks for itself. I spent a few months kind of getting to this. This really was the big, all right, I'm going to deploy all this new refactored code using basically best practices. Like you read any of the great articles that Microsoft MSDN has, we had generated Bootstrap just kind of getting things done and deploying, which is great. But now that we've kind of matured into a real company and I'm doing real things, it really was valuable to kind of address tech debt. I don't know, I'm sure everyone out here can look at some old code and be like, that sucks, I hate it. It really makes my life difficult. And luckily I had great managers and great team around me really allowed me to look at what we were doing and like, all right, I'm going to step back and redo this. I mean, I don't know how well you can see the scale, but we were at like 300 milliseconds, 250 milliseconds, and that immediately dropped down to 50 milliseconds. You can ignore the red lines. That was during deploy, it was kind of all or nothing. So that was huge. That was literally just still 4.6. It was exact same code, exact same endpoints. Not exact same code, sorry. It was the updated code to use dependency injection and kind of back away from this massive singleton that was passed around that probably wasn't thread safe, that was context switching happening all over the place. So that was huge. So now this is where we are. Like, it's great. I can quickly work and deploy code changes, things like that. There's no more spaghetti code. Whenever I want to make changes to our data model in the database, I literally just run the code generator and I can start coding. I have DevOps on my side. Like I kind of, that was behind the scenes. Still works. Still don't have unit testing. But it's old in my mind. So like I said, I worked at a traditional kind of cube farm right out of enterprise company. We got stuck on .NET 4 the entire time I was there, and the traditional framework. And I was just like, I'm not going to do this. I had seen some blog posts about how fast the new stuff was. And honestly, like you probably maybe see that I'm using a MacBook. Working and troubleshooting stuff on the weekends really was a huge challenge. So say something would happen with our data provider and they would mark a fumble as a string instead of a float. Our serialization would, hiccup. I need to check it and make sure something's not broken. Starting up Parallels, while Parallels is great for day-to-day, I can't get in there quick. So if I'm able to run VS Code and kind of get in and, oh, look, run, it's just this one thing. I don't have to do anything else instead of spending 30 minutes while my laptop fans kind of click on. That was huge, and honestly, probably for a little personal and selfish reasons. So to get into this is just kind of an overview. This was our architecture. You'll see here that Wrangler kind of takes messages from the front end so we can manually run jobs. The Marshall scheduler really is the thing that's kind of powering if auto scheduling games, things like that. Generally speaking, we're at a good place. Like, this works. This is still what we're running today. Yeah, we're all good, but I want to upgrade everything to .NET Core. Luckily, I had spent all that time refactoring, and what's left to do? This is where I was probably 3 months ago. I reached out to Scott. He gave me a bunch of back and forth on things that I can work on and maybe look at. Had some talks with them. Really, the only thing that was done, Serial and Wrangler, already just kind of worked by principle of how they work. The startup was a little bit different because we're using Kestrel and the IIS integration was weird, but it just worked. The authentication model was different for our Wrangler kind of front end. The big thing there was, I think Microsoft kind of makes you want to take a step back and not just use some auto-click thing. Data breaches are all in the news. You need to know what you're doing. They have a ton of good resources on that. I follow them along perfectly, and we kind of rolled our own custom thing. There's no more app code directory, so helpers don't really exist anymore. We were using those throughout the place, and we were very incorrectly. Easy, quick change for that was just using partial views. The data protection keys, I know they used to use a machine key, which actually was kind of a pain because we had hard-coded stuff in our web config. Now they have some distributed caching support for that. Really easy fix. That was already done and documented by Microsoft. And then we didn't have New Relic support, but luckily we have a really good relationship with them. They reached out to us and kind of gave us, like, here's our alpha agent. We got it running perfectly. So with that said, those were probably maybe a month's worth of work to get kind of going. Turn on our servers in AWS and then deploy the code. And here's what you see. Still don't have unit testing, but it's a lot easier in .NET Core. Less code, cross-platform, I can do all these things. And I think the numbers, I know I'm running low on time, the numbers really speak for themselves, so I can just kind of leave you with that takeaway. Serial or serialization process, I mean, these numbers really do speak for themselves. Just this was code for code, the exact same. There was no copy, it was all copy-pasted, running in parallel. The same number of requests is over half the time. So it was huge just going to .NET Core 1.1, then going to .NET Core 2.0 was 240 milliseconds, like literally half the time. So that's huge. Wrangler, the middle metrics don't really matter because we only ran it in production for maybe, once we saw that .NET Core 2 was huge for serial, I was like, all right, I don't really want to mess with that. So like the sample size of that was only maybe like 120, and depending on what you're doing, that's not valuable. But even Wrangler, which is basically network bound, so there's even clearly improvements with the network operations. The aggregates are the same. There's 300 milliseconds off that. And then this is huge for our front end metrics. Again, same code parity or feature parity. Average response time on our old, even that new latent great thing was 32.8 milliseconds with 50 RPMs. And that, that's great. We actually changed some of our caching strategy. Now we're at 5.1 milliseconds with a much greater RPMs. And a lot of this was changed because we're like I said, we're already providing the kind of scores and stats and things like that in the application for teams that we're kind of expanding on what you see and some new things that are going to actually be coming out. So I know that was a lot of information. I hope you kind of saw like .NET can take you from this Hello World app to this big grand architecture to what you kind of want to do and use in your real world, and I love it. I'll take some questions because I think there's actually one's actually relating to this. So here I'm going to leave this up here. So if you want to see my email address, shoot me a question or shoot me some emails, and happy to answer them. One of the questions is, why did you choose .NET for your architecture? Like I said, we came out of college and we were working at this place and they were using .NET. Honestly, it was what we were comfortable with. I knew it was great in production. At the time, I don't know if they still have it, Microsoft had a program called BizSpark, which was great. You could get kind of access to everything. It really was. It just was comfortable. It had great kind of feature support for things. The community was good. I came from Java where I liked Microsoft's take. They provided a ton of stuff that just worked. And honestly, it was just convenience. Other question, in addition to EC2, were you paying for the data as well? Yes and no. When we were getting it, before we actually launched the whiteboard product, we kind of worked with Sportradar, and the assumption was, if you guys become profitable, great. At the time, they were kind of competing with Stats LLC. They still are. I don't know why I said at the time. And I think it was a good exposure for them. So once we actually made the whiteboard deals, we had some kind of agreement, I don't remember specifically what it was, that kind of allowed them to make a profit on kind of piggybacking us. And honestly, that wasn't anything special. It was just reach out like, hey, can you help with us? And then finally, there's another one, do you use Signal or any other type of push notifications with ASP.NET? We actually were, with our Wrangler process, we had a monitor that would actually kind of work in the background, and we would use that to kind of send messages to serial from Wrangler, things like that. Again, when I did the refactor, kind of took a step back and realized like, oh, I don't really use that much. And I know with the .NET Core stuff coming out, there was some kind of like, oh, is it going to be ready? Isn't it? I think the only thing we were really using it was to send stop messages between things or like cancel messages. It was great and it worked perfectly. Honestly, it was just like, all right, I don't want to support this myself because I'm one of the only developers on this. So I think that's all the questions I got, and I covered a ton of stuff. I hope I didn't ramble too much. I can feel myself talking pretty fast. But if you have any questions to get into more specifics, I can probably go over some code on how we do things. Here's my email address. You can hit me up on Twitter at richman777. Probably respond on email, probably a little bit better, but feel free. And if you have any other questions about either Bleacher Report or StatMilk or how we're using .NET, yeah, hit me up, and hopefully that was good. I think we're out of time.